Hello, ladies and gentlemen. Today we will be talking about chemical bonding, properties and bonding of ionic compounds. Just ionic. After today, you should be able to write formulas for ionic compounds, explain what an empirical formula is, describe the properties of ionic compounds, and model the formation of an ionic compound using Lewis dot diagrams. First, we have properties of ionic compounds. Ionic bonds are very strong. They are solids at room temperature. They have a high melting point and a high boiling point. They are made of a metal and a nonmetal. They do not conduct electricity in their solid state, but they do in liquid and aqueous states. And aqueous means dissolved in water. So whenever they are dissolved in water, they can conduct electricity. Examples, the formation of ionic compounds. So we use electron dot structures to predict the compound that would form between sodium and fluorine. So I have sodium, which is Na, and it has one single dot. And then I have fluorine, which is F, and it has 7 dots around it. Now that is from our last discussion, our last notes. So if you don't remember that or don't understand where I got those from, go back there. Now what happens is that this sodium gives up its electron and gives it to fluorine. Okay? And we need one sodium and one fluorine in order to do that. So in order to write the formula, we write the anion first. I'm sorry, the cation first and then the anion. So we have sodium and then fluorine. And we need one of each of those. In our next example, we're going to have electron dot structures to predict the compound that would form between magnesium and chlorine. So first I draw magnesium, Mg. Magnesium is in group 2, so it has 2 valence electrons. Then I have chlorine, and chlorine has 7 valence electrons. Now what happens, magnesium wants to get rid of both of these, so it gives one to this chlorine, and then it's going to give the other one to another chlorine. So we have to draw our other chlorine in here. And it's going to give this electron to this chlorine. So the way we write that formula is going to be Mg and then Cl2. For our next example, we will be doing electron dot structures to predict the compound that will form between aluminum and sulfur. Okay. So first we have aluminum. Aluminum has 3 valence electrons. Sulfur has 6 valence electrons. Okay. So aluminum is going to give up 2 of these, 1 for each of these sides. And then it has 1 left, so we need another sulfur. So I'm going to draw another sulfur. So it's going to give up this electron to this sulfur. But then sulfur isn't happy because it needs another electron. So we're going to draw another aluminum. And aluminum is going to give this to this sulfur, so it's full. But now aluminum isn't happy, and it has 2 more electrons that are valence electrons, so it wants to have another sulfur involved. So we draw yet another sulfur. And then aluminum gives these last 2 electrons to this third sulfur. Now, what is the formula for that compound? We have 2 aluminums and then 3 sulfurs. Next concept, we're going to talk about empirical formulas. And empirical formulas are simply the chemical formula for an ionic compound that is arranged in the smallest whole number ratio. When we think back to our last chapter, it would be when we have to simplify that we get an empirical formula. So it's the lowest ratio that we can possibly go. An example would be if we had magnesium 6, nitrogen 4, we could obviously simplify that to Mg3N2. So the empirical formula here is Mg3N2 because it's the simplest that you could possibly get. Here's a little cartoon for you between sodium and chlorine. Just a little fun. Now you have homework. We are not doing the exit ticket. We are just beginning with worksheet 2, the homework. All right. You guys let me know if you have any questions. I'm obviously available.